So in the last section, we saw the idea of an array, which was really a collection of data that could be referenced in really any sort of way, right? We could index an element somewhere in the middle. We could add elements anywhere in the array. We could remove elements anywhere in the array. But the thing about it was that the actual operations that we had available in the array came at a cost, right? No matter what we were doing, there was a chance that we would have, an O of n operation or something that was relatively slow comparative to constant time. And this sort of thing is okay if we want to be able to reference data at any sort of point. But oftentimes we don't need to be able to do that. So for those sorts of circumstances, we want to consider data structures that give us the same sort of flexibility that we need without giving us too much flexibility such that we end up with slower operations because of it. One of the first data structures that we'll talk about in this sort of respect is a stack. A stack is a type of data structure which we call a LIFO data structure. LIFO means last in, first out. So the last thing that we put on a stack is the first thing that's removed from it. And when you're thinking about this sort of intuition, I encourage you to think about it like an actual stack of things. I've often heard like my teacher say like a stack of plates, right? If you have a stack of plates, when you want to put something on that stack of plates, so you want to put another plate on, you place it on top of that stack, right? And then if you want to remove something from that stack of plates, you remove it from the top as well. So you see that you're always working off of the top of the stack. So you're either placing things on the top or you're removing things from the top. As opposed to like an array where we can access in any sort of location. In this case, we're only working with that topmost thing on the stack itself. Now where this comes in really useful is in situations where we want to be able to remember the last thing that happened or the last thing that we saw, sort of the most recent type of item, right? That's one of the main reasons why we would use a stack. So if I wanted to remember, say, the last element that I saw, I may place it on a stack, and because it's last in, first out, the thing on the top of the stack will be the last thing that I saw, right? That's sort of the idea of when we're using a stack. It's to sort of look at things in terms of when they happened. Taking a look at the most recent thing that happened would be a pretty good use case. Before we dive into the more of the use cases and implementation, though, I want to give you a bit of intuition around how this stack is really working. So suppose that we had a few different values and we wanted to get them onto a stack, right? There's three main methods that we have available in our stack. Those would be a push, a pop, and a peek. These are our three main methods. A push is going to place a value onto the stack. So, for example, if I were to push the value 1 onto a stack, if the stack were empty, well, 1 would just become the top of my stack, right? Now, if I were to take this same stack and I were to push the value 2 onto it, what would happen is 2 would become the new top of our stack. So basically 2 goes on top of 1. It becomes the new top. And finally, if I were to push 3 onto this stack, the same sort of thing would happen. 3 would become the new top of the stack, and everything else would sit below it. So what about our other two methods? Well, the peek method we'll talk about next. All the peek method does is it tells us what's at the top of the stack. So in this example here, the peek method would return to me the value 3, since 3 is the value that's currently on top of the stack. The pop method removes the value that's at the top of the stack. So if I were to do a pop on my stack, it would still return to me the value of 3, but it would also remove 3 from the stack. So my stack would now just be the values 2 and 1, and 2 would be the top of the stack. This value 3 was actually removed from the stack. That's what the pop actually did. So those are our three main methods that we have available to us. All of these methods should be able to be completed in constant time, in the worst case. So that's the main power of this. We're going to be able to access the most recent value that we've seen, so the last thing that was added onto the stack, and we can do that in constant, or O1 time, right? So that's the main idea of a stack. I just wanted to give you this intuition so that when we get into the implementation, you understand generally what we're trying to do here, and then the implementation will be easy, and then in turn, the example problems will make a lot of sense, and you can see all these different applications and start to use stacks in your own coding. So thanks so much for watching this video, and I'll see you in the next one.